Hey everyone, so in the last chapter we looked at all the very important basic functionality of Houdini, how to copy geometry, how to deal with attributes, what's the difference between packed and non-packed geometry, what are volumes, all this very important base stuff. And in the next couple of videos we will actually go into the simulation topic. Now before we do this, I wanted to talk about one very important topic, and that is resource management. Because what we do in FX is really resource hungry, which is one of the reasons why I do not recommend working with a laptop. It's simply not built for our kind of work, because what we will see at some point, sometimes we are prepared for it, sometimes we're not, is that we will use a lot of RAM, for example. So our simulations will eat up a lot of memory. But before we talk about this, which is a very important topic, let's talk about how to actually find out what our computer is doing. Because I see this all the time, that people ask on Reddit or on Discord or whatever, look at this, my computer is freezing or Houdini crashed. Why is that? And then the first question I would always ask is, what is your RAM doing? And very often the answer is, I don't know. And this is not a good answer. You should always know what your computer is doing, and how to check this depends on your operating system. But no matter what operating system you're using, there's always some kind of system monitor or performance monitor or resource manager, something like that, that tells you what your computer is currently doing. On my main machine where I use Linux, you can see there is a tab called resources under the system monitor, and it's not the best way of showing this because I have too many CPU cores, but you can see here on the top it shows my CPU usage. So right now I'm using about 10% of my overall CPU power, and down here I can see my memory, and I can see I'm using about 43% of my 128 gigabytes of RAM. This information should always be available to you. You should always have this system monitor or the equivalent in your machine open to see what is going on. What I have installed, and maybe you can find something for your operating system, is even a constant indicator that is part of my taskbar. So here you can see what my taskbar looks like, and next to all the windows that I have open, it shows me the usage of my CPU, my memory, and even other informations like my disk usage and network usage. So I'm always 100% aware what my computer is doing, so that I'm not surprised if my Houdini crashes because my RAM is full. Now, when you're on Windows, it's pretty straightforward. You just open your task manager where you can see all your processes. The quickest way to do this is pressing Ctrl, Shift and Escape, and then under the Performance tab you can see all the resources that are currently used. So this is my Windows machine, which has 64 gigabytes of RAM, and here I can see how much of it I use and how much my CPU is doing. Now, before we talk about the RAM usage, which is very important, let's first talk about CPU utilization. So when I look, for example, at this, which we haven't talked about yet, I'm aware, but this is a flip simulation, so a fluid simulation. And when I look into my performance monitor, I can see that currently my CPU is fully used. So this is not a surprise. This is what we would expect. My computer is 100% busy calculating that fluid simulation. Now, when I look at another example like this RBD simulation, which is a rigid body simulation where I'm constantly emitting these boxes here, and I emit way too many. Every frame I emit 2000 new boxes or something, which are pretty dense in the resolution, which of course is only a test to show how to really make my computer busy. And now I open my task manager, something surprising is happening, that the CPU is actually not used 100%. And this is something that has to do with parallelization or multi-threading. So as you can see up here, my computer, my Windows machine has 16 cores, which means basically 16 CPUs or processors are together building my processor. This is the reason why modern CPUs are so fast, because they can split up the work into 16 different workers. In your case, it's probably 8 or maybe even more than 16. But either way, modern processors have multiple cores. This has the advantage that you can do actually more work in shorter amount of time. The disadvantage is that these 16 cores cannot communicate with each other, which means you can only work with those 16 cores if they can actually work in parallel without having to communicating about the same data. Without going too deep into when this happens, certain simulation types cannot actually be multi-threaded easily. So not all simulation types can actually use all your cores in parallel. Some simulation types can even only use one core at a time. So don't be surprised if your CPU is not using 100% of its potential. Certain simulation types simply can't do that, because they can't use all of your cores in parallel. They can only use one or maybe a few. You didn't do anything wrong. This is normal. Now let's talk about memory usage. And for this, I just did a simple setup here that you should understand. I have a sphere here, nothing special, with some distribution. And all I'm doing is I use a second sphere and fill this with the points from volume. And what I do is simply using a lot of them. So I will now copy this sphere onto those points without packing the geometry. And I should end up with a couple million points. And when I do this, my computer will start to really fill my memory. And on my Linux machine, you can see this down here. It fills up from 55% to 55.3, 4, and so on. So it's slowly filling up. And my Linux machine is a bit better handling RAM, but we can see the same when we look at my Windows machine. And now if I do this in my Windows machine and open my task manager, and more specifically the performance monitor, you can see that currently my memory is at 22%, so this is just what Windows is using. And if I now do the same that we just saw in the Linux example, you can see now that my RAM is filling up here much quicker, also because I have less RAM. So you can see how it goes up and up and up. And I'm speeding this up a little bit because it takes a while. But at some point you can see it will reach 100%. So basically my RAM is full. Now this will very often result in your Houdini crashing, or it can even result in your Windows machine crashing. The important thing here is this should not surprise you, because while you're waiting for something, you should always look into your task manager and check what's actually going on. So if your machine or your Houdini is crashing because your RAM is full, then this should never be a surprise, because you can see that in your resource manager. Sure, that just shows you that you did something wrong and you might be able to optimize something, but it should not be a surprise to you, because you can see what this curve here is doing. And once my Houdini is crashed now, you can see now that the RAM of course goes down again, because it frees up the memory that it doesn't need anymore. The whole point here is that this can happen, but you should always be aware when it happens. Let's now talk about another topic. Let's assume I did not overuse my memory, so my system or my Houdini didn't crash, but I simply used a lot of resources. And this is actually quite common after you simulated something and so on. You will notice that your RAM is pretty full. So in my case, I used 80% of my RAM. And you might wonder how to free this RAM back up. So first of all, inside of Houdini, what you can use is the Windows Cache Manager, and this looks like this. And then all kinds of things use a certain amount of RAM, the display and some caching for the sub level and so on. So there's a lot of stuff, and you could one by one clear them with the clear button, or what you can do, what I do, you just press clear all. And the interesting thing is it actually works to click on it multiple times, and you then clear more and more and more up to a certain point where you can't clear it anymore. Here in this case, it could help to just go back to free my sim memory and then try this again. You can see now I went from 12% to 11%. So you can keep improving this, but there is a certain limit where it doesn't go further. And even when I press here clear on this very high bar, then nothing happens. This is very unfortunate. It helps a little bit. So when we look at the system monitor, we can see we went down by only 2%, but at least that happened. But it still uses all the rest. And this is something that I can't really explain to you. This is just a really annoying thing about Houdini. When you know that you don't need any caching, and you know that all the RAM usage that you see in your system monitor is more than you would expect, then the trick is simple. You just have to close your Houdini. And what you will see is that your RAM usage will drastically go down after your Houdini has closed. Yes, this is a bit annoying, I agree, but at least you know now that this is a way of clearing up your RAM, if you're sure that you don't need it anymore. And now if you would open Houdini again, then you could start basically with an almost empty RAM minus what your operating system needs. All right, so you can see that resource management is very important in our line of work. So you should be familiar with how to check what your machine is doing. This is very important. And if someone asks how your RAM usage was before your Houdini crashed, the answer, I don't know, is not acceptable, because you should always be aware what your computer is doing when you're working with simulations. So I hope this is helpful. Thanks very much and see you later. Cheers.